Hi, good afternoon. This is Stan Price with the Smart Building Center, and welcome to part 2 of our executive forum on building electrification and grid interactive efficient buildings. Welcome to many of you participants who attended last Thursday's session on this particular topic. And I'm pleased to say that we're have an equally interesting and qualified panel to talk about some of the issues today. So just a word or two about the Smart Building Center before I ask our panelists to go around to do self-introductions. The Smart Building Center is a 501c3 educational nonprofit organization based in Seattle, which is dedicated to cultivating the market for smart and operationally efficient buildings. And so this is the kind of thing that we do periodically, offer these educational events. And on an annual basis, we offer a significant conference, the Smart Buildings Exchange. And at the end of our session today, I'll actually be posting an announcement that this year's edition, the 2022 edition of the Smart Buildings Exchange, is now open for registration, set for August the 22nd to the 24th. So hang on till the end today, and you'll get a little bit more information about that. To our audience, we asked you during the registration process if you had any particular questions that you wanted to pre-submit for our panel to discuss. And many of you took advantage of that, and we appreciate it. To let you know, I have reviewed all those and tried my best to integrate, at least thematically, the thrust of these questions into some of the topics this panel is going to be addressing today. However, if there's additional questions that you have or things that you'd like to have clarified, please use the question and answer box. We'll do our best to moderate that throughout and try to address as many questions during the discussion today as we can. With that, I think let's get started. We've got 4 really great individuals to have a conversation today about building electrification and GEBs. Today's discussion is going to be a little bit more, what I would say, market-centric, as opposed to a bit more utility-centric discussion that we had last week. So I'm really looking forward to the discussion. I'm going to ask Marianne Piet to begin by introducing herself and telling us a little bit about what role you play at Lawrence Berkeley National Labs.
Hello, everybody. It's thank you, Stan, for setting up today's event, and it's a great pleasure to be here. I am the division director of a division at Lawrence Berkeley National Lab that does research on buildings, and the name of the division is the Building Technology and Urban Systems Division. But I also was an author on the DOE roadmap on grid interactive efficient buildings. And I've been working in demand response in California. I run something called CalFlex Hub, which I'll talk a little about later, but really trying to create technology, value proposition, interoperability, and demonstrations to help accelerate adoption of grid interactive efficient buildings and conduct the research to help reduce the risk of investment in these kinds of technologies.
Perfect. And I will say, now that you have referenced this roadmap document, that if folks want to migrate over to the chat, I think my colleague Britton has posted a link there. So if you're not familiar with this document, go over there, take a look. It's really a must read for folks who are interested here in this. Brett, you next with the Rocky Mountain Institute.
Yeah, Brett Bridgeland. I'm a manager with RMI in our carbon-free buildings group. My background in architecture and engineering, and what I'm doing at RMI right now includes work on grid interactive efficient buildings and demand flexibility. It's a topic that we've been digging into for 6 or 7 years now, both from the building side and also from the grid side of things. And so we've done a number of studies in recent years on looking at the carbon reduction potential and some other some other sort of top-down analysis of demand flexibility. And I think as a lot of the market is right now, we're starting to shift towards how we translate that into implementation and action. So looking forward to the discussion.
Great, thanks so much. Saloni, you're next, please. You're, as I said before, we actually came live on this webinar. Yours is a voice we sometimes don't hear, certainly don't hear enough of in these kinds of discussions. So I'm super happy that you're able to join us today.
Well, thank you very much for having us on this panel. I'm Saloni Habibuddin. I'm Vice President of Development at Urban Visions in Seattle. Urban Visions is a privately held development company led by Greg Smith. We develop, hold, and operate our buildings. And we're currently developing, hopefully, the next generation buildings, about 2.4 million square feet spread over 4 projects. I'm originally an architect and I moved into development, and having overseen several buildings from inception through occupancy, I would say, and post-occupancy, you know, I have to live with what we build and the decisions that we made, the good, bad, and the ugly. And to that end, you know, our focus with our portfolio is really human health and environmental well-being. Everyone knows we're a developer, but that's what we focus on. And to achieve this, we are constantly educating ourselves. We are trying to execute on that gained knowledge, and we try to lead by example.
Perfect. Thanks so much. And really looking forward to your comments throughout today. Hendrik, you and I have actually known each other for a long time, but for those of us in the audience, give us a little bit of background.
Yeah, well, thank you for the opportunity to join the panel, and thanks for everybody out there listening. I'm the managing director of EDO, and EDO is a newer company. We're about 50 people strong. We're focused on unlocking the potential of buildings to be better energy performing resources, both for the grid and for the occupants. So we actually were born out of a project in Spokane, Washington, which is where I am today, where we built a living laboratory really designed to prove the benefit of GridInteractive efficient buildings in partnership with Avista and McKinstry, which are our founding companies. So yeah, I'm super excited about the conversation today.
Great, thanks. And for those who were with us last week and got to know John Gibson from Utilities, who mentioned a bit about the Catalyst project in Spokane, that's directly the project that Hendrik is talking about here today. So you'll have a little bit of background from John's explanation, but Hendrik can also talk about this project really from the other side of that coin. So we'll appreciate that discussion. Well, I hope the audience agrees that this is the perfect panel for this kind of discussion. We're trying to bring together a couple of, or at least in my own brain, we're trying to bring together a couple of conversation streams that that sometimes come independently, but I think hopefully you'll agree at the end of this discussion need to be integrated, which is thinking about building electrification and the movement towards building electrification and the technology and practices associated with grid-interactive efficient buildings. We're going to begin, as we did last week, with defining some terms. Building electrification, I'm going to let stand as something that is fairly self-explanatory in the 2 words itself, although panel, please correct me if I'm wrong, and we want to put a sharper edge to that. But grid-interactive efficient buildings is at least a bigger mouthful in relationship to thinking about it as a concept and a technology. So I'm going to start by asking Marianne, because she's one of the authors of the US DOE roadmap, the document on GEBs, to give us a little bit of a definition here and correct any misconceptions I have that this is really the same thing that we talked about 4 or 5 years ago when we said high performance buildings.
Yeah, thank you. So high performance is a great term. We still want high performing GEBs. And I want to put the discussion in the context of sort of history. Many of us have spent decades on energy efficiency, and energy efficiency allowed us to reduce the need to build new power plants help us to create more value for the American consumer by reducing their bills. You know, when you put in efficient equipment in your home and put in good insulation, you save money, and it can have a really low payback, a really fast payback. But as we create a change in the electric grid, and we have more renewables on the grid, whether they're wind or solar or wave power or other sorts of things, we have a changing energy supply system. And in order to facilitate the most affordable clean energy, we need building loads, demand side loads, to be flexible. And that is, we want them to use as much energy as we can at the time when those renewables are abundant, and to use less at times of the day when they're less abundant. And that the time scale of that can be hours, even days. It may be a wind event is a couple of days long, and then there may be days when there's clouds and less wind. But the main concept is we care about the electric load shape. So energy efficiency is about reducing total energy. It's not just how much energy you use, but it's when you use it.
Okay.
So a grid interactive efficient building has both energy efficiency. We don't want grid interactive without energy efficiency. So a lot of effort was put to combine those. And the attributes of load flexibility typically means that there's going to be some sort of smart communicating and controls, sort of like high performing buildings. And we're able to receive signals from the grid, and we have controls and communications that can allow the building to be responsive, whether it's a heat pump or an HVAC system or a light, or even integrating with storage systems, electric or thermal. So essentially, the concept is that we want to be able to price electricity that's consistent with the grid conditions. And the building is getting low prices when there's plenty of that clean, low cost energy, electricity in particular, and to actually move its load from other times. And so there's a lot of ways we do that, but the basic idea is that we want the building to have controls and communications, and we want a consumer interface so the people in the building understand what's happening. And there's a lot of business models to deliver this, but essentially we want to have the ability to have electric load flexibility. So that hourly load is a really important part of grid interactive efficient buildings. And we want to make sure that the building is still energy efficient. So we're not putting in technology that can just move loads around in an inefficient way. We want to make sure we're still delivering energy efficiency, because that's kind of the front lines for customers, and they're making their bills more affordable.
Thanks. Brett, Marianne just described to me something that sounds heftier and more challenging than demand response programs, which have been around for a long time. Did you hear that same thing? Are we distinguishing something here that's different and apart from what has been really on the table for a while here in relationship to periodic calls by a utility for customer load reductions?
Yeah, and we think about that distinction too, whereas traditional demand response is sort of isolated events to solve specific peak load problems. It's fairly manual traditionally, like even picking up a phone to make calls to major loads. Whereas demand flexibility or grid interactivity is more real time, and it's reacting to more real time signals. And so, I guess one thing to sort of explain is that is dispatch order on the grid. And so this is a grid issue, but it's relevant to this conversation. So the way electricity generation works is that the cheapest generation, this is kind of a simplification, but the cheapest generation gets dispatched first. And then as load increases or demand increases, you turn on the more expensive things, so that the last thing that's turned on and ramping up and down is the most expensive. And often, not always, but often that correlates with the dirtier generation, dirtier peaker plants. And so the thing that's sitting on the margin, that last thing that turned on, if we can get that to turn off or ramp down, we can see some significant carbon reductions. And so we've been doing some modeling in different contexts on this. And what we see is as the grid becomes increasingly renewable, the carbon benefits from turning down loads or shifting loads on the margin tends to increase. And so there are some examples, like this is starting to creep into high wind penetration grids or high solar grids like California, where we can take real data and run analysis to see what the carbon reduction potential is from hourly load shifting. And what we see is it's significant. It's something north of 10% CO2 savings from being able to shift load from a dirtier hour to an hour where there's higher renewable penetration. And in some cases, like we ran numbers on Texas, I can share a link to a study where it was north of even 20%, and by the way, reducing curtailment of renewables by like 40%. So there's some really exciting possibilities there in terms of direct attributable carbon reduction. One of the interesting things now, or the new challenges for our building sector, is getting that data so that we can make decisions. So RMI a couple of years ago started, or actually we just spun it up. We spun off this company called WattTime, and what they do is obtain real-time grid emissions factors from everywhere in the US and parts of Canada and Europe, and they're expanding, and post them to an API so that that's available and it's something that aggregators or solutions providers can tap into and get these real-time signals. And so that's an exciting development as far as implementation. I would also point out that because this hinges so much on what the grid mix is, and we're trying to look towards the future, there's this interesting modeling exercise to figure out what hourly load profiles or generation profiles look like. NREL's Cambium data set is one that is attempting to do that, to look into the crystal ball and see what hourly generation mix profiles look like. But this is kind of at the forefront of analysis and harnessing this new carbon reduction potential from load shifting.
Perfect. Hendrik, I want to get inside the building a little bit. We've had the term, kind of load flexibility thrown around. This is a resource. How do we flex these loads? You're inside of buildings. Give me some examples. What kind of loads are we talking about here? What's amenable to this sort of flexibility?
Yeah, great question. So I think a couple of things. I mean, I think at a high level, what Brett was really kind of alluding to is we're trying to decarbonize buildings, right? Individuals, building owners, building occupants, there's a collective desire to find ways to decarbonize buildings. And I often get asked the question of, why don't we just put more batteries in buildings, right? Wouldn't that solve the problem? And if you kind of step back and look at the overall system and think about the way we generate electricity and the way we consume electricity and potentially store it, there's a more cost-effective, equitable way to do that than just to have those that can afford to put batteries in all of their buildings. So we're really trying to find solutions that are a little bit more robust. And when we think about grid interactive efficient buildings, we don't think about big occupant impacts, right? An occupant doesn't necessarily want to think about in real time what the grid carbon mix is. They're looking for an outcome, right? That building was built for a purpose, right? It's a place to learn or to heal or to work. And so we want to support that building's mission. And so a lot of the interventions are really things that we try to do behind the scenes, right? So an occupant doesn't even experience a change in environmental conditions in their space. The other thing worth noting is that there are times when an occupant would probably prefer to dim their lights than have the power go out. right? So there are interventions that can be deeper and more impactful, but they're an alternative to an outage or a bigger disruption. So we think about not just that little incremental change, but also bigger interventions at certain times, a couple of times a year. And part of the process of making this a reality is really understanding our stakeholders' goals and then aligning those goals with the resources they have. So it could be dimming lights, it could be changing set points, it could be actually thinking about the way a building can kind of hold thermal mass based on the design of the building. And so maybe you can change the way equipment is running in short durations without impacting comfort. So there are lots of interventions. Won't go through all of them, but the point is that we're not trying to make interventions that impact occupants in a negative way. We're trying to make that experience for an occupant even better, right? They get the experience of being in a decarbonized, highly efficient, high performance building that suits their needs. And we're doing so in a way that supports the grid as well.
Great, thanks. That's really helpful. Saloni, I'm interested in your perspective on this conversation. It seems like to me that I participated in a few thousand workshops that were targeted to building developers, owners, and managers that sort of talked about the merits of, quote, sustainability. How does all this ring in your ear? Is this part of a continuum discussion in terms of reacting to sort of the concept of sustainability? So I'm just asking, how does all this play in the ear of a developer?
Absolutely. And I'm gonna, Marianne and Brett and Hendrik, they brought us from 30,000 foot, and I'm gonna come down into the weeds and talk about the pragmatic aspects of everything that they've talked about. So one thing I want to say, that this is something that cannot be on the back burner anymore for developers. It can't be an afterthought. The electric grids are becoming more unreliable. This is not a judgment, I assure you. It's just a data point. And as developers and asset holders, we really need to pay attention, and pay attention now. To share what drives our thinking as a developer, I'd like to first give you some context, and in which the realm that we operate in. Then I want to tie that to the GEB report and to everything that Marianne, Brett, and Hendrik are doing. And then I want to give you a practical example of what we did as a developer. So on the context side, there are two things to it. As developers, it's what Hendrik said, we serve 5 stakeholders. We've got tenants, operators, capital partners, and environment and human health. They're a Venn diagram. One isn't any more important than the other. They're all interconnected. The second context I have to give us is Moore's law. Technology moves at the fastest pace. The next is social adaptation. And the third and the slowest is the built environment. And the reality is that our physical assets will always be, at least for now, will be behind technological innovation. And we don't know what technology is around the corner. The only way to bridge this gap is from day one is designing our assets in a way that have a great, well thought out network architecture for flexibility, reliability, and future proofing. That's really how we can bridge that gap to enable then what, Hendrik and Brett and Marianne want to enable. I want to tie this. The next thing I want to tie it to GEB and what they're trying to do. When you read their report, the number one barrier that GEB has set to deployment is interoperability and connectivity. Conversely, also in the report, it says the number one pillar for the successful deployment is through research, data, and development. And I'm going to grasp onto the data portion of what this means to us. The only way to create a platform for GEB is to get great data, is to have a well-designed connected network infrastructure in our buildings, because this teaches us about our usage. It teaches us about our behavior patterns. It helps us analyze how we're going to be more efficient with our energy usage, and this conversation, this two-way conversation we now need to have with the grid. So given all of that, the pragmatic, so what did Urban Visions do? What did we do? And we're, remember, we're learning as we go as well. We're not like the gurus of this. But we did make 3 very clear moves in this next generation buildings. Number 1, we made our buildings all electric. In the Pacific Northwest, we're very fortunate we have hydroelectricity. We did not use gas for heating and cooling, and gas is only there now for retail use, and we're trying to eliminate that as well. The second move we made was on-site renewable energy. We've got over an acre of PV panels on one of our projects, which is equivalent to 8% of our energy usage. And the third one is coming back to what you're going to keep hearing me say, is the deployment and incorporation of network architecture and infrastructure. This includes extra controls, extra sensors, an efficient backbone, making sure the systems are all talking to each other. And there was number one goal behind all of this. We wanted to collect usable data. So I'm going to pause right there.
That's, I have 1,000 questions based on that really good response, Saloni, but I'm gonna see if any of the panelists want to preempt my next question and just respond to the conversation.
Yeah, I really appreciate Saloni's vision and appreciation for the technical challenge related to the network, because we know that facility managers often have no idea what's happening at zone 7 in building 2, but you save money on maintenance when you have this infrastructure as well. So there's a very practical reason. When we talked about high performance to start, smart buildings, that concept's been around, and that is a fundamental building block for GEBs. That you invest in controls, communications, monitoring, data acquisition, smart analytics, energy management information systems. And we know from work on this, we ran something called the Smart Energy Analytics campaign. We had 700,000 downloads of the Smart Energy Analytics report. And facility managers want this technology. So I really appreciate Saloni's vision for the role of that kind of technology, and it supports energy efficiency, it supports cost management, it supports facilities, and it's a really important topic.
Well, I was particularly struck, Saloni, as you were speaking, because it gave me a much better refinement to the way I'd been thinking about this problem in my own head, that GEBs thinking about this as one of the tools associated with solving some very specific utility modernization and grid reliability issues. And whether or not people on both sides of the meter sort of assumed or looked at that question in the same way. And my goal had been, why can't we all think about this in the same way? But I think your discussion really helped galvanize the notion that the value proposition is very specific to the folks who are part of creating and maintaining the built environment, separate and distinct from the utility system. Which leads me, I think, Hendrik, to the question of there are new business models out there now that are trying to figure out how to help both parties achieve their goals here. Do you want to talk a little bit about how you see kind of third-party providers like Ido and others now playing a new and important role here?
Yeah. I think that there's a couple components, and I want to pick up on what Saloni said and also what Brett said around watt time. So on both sides, there's this need to unlock the relevant data and information and then make that available across the meter, right? You can't optimize a building for carbon if you don't know the real-time mix of carbon on the grid. And similarly, the interventions that will drive carbon out of the utility mix are very different by location, right? So the way in the Pacific Northwest, which is so hydro dependent, you might have a much different set of interventions that drive the most carbon out relative to California, which has this duck curve afternoon, ramp up problem. So each market will have different solutions. I think when we think about the kind of this space relative to business models and partnership models, I think a lot of it needs to be market-based, right? We need to create the right incentives through pricing and through tariffs, right? We currently incent things from a utility perspective in sort of a strange way, right? Rates don't perfectly match what the benefit and cost of resources are in that moment. On the flip side, if it's so complex and it's so real time, it's very hard for developers and building owners and operators to make sense of their utility bills. So I think there's a role to play for partners to step into that space. And for EDO specifically, we really see the utility stepping farther into supporting their clients and supporting building owners and operators making decisions about capital planning and operational planning, because utilities have an important sort of in the regulatory construct, they have responsibility to think about equity and affordability and scale, and purely market-based solutions where you can take advantage of maybe price arbitrage on wholesale markets. That might be part of the solution, but that might miss some of these other key criteria for this kind of just energy transition around, in order to get to scale, to have an affordable solution that is equitable for all stakeholders. So we really, I think the role of utilities needs to change. And, there's been lots of, it's not a fast moving space, as we all know, but there's been lots of promising movement towards trying to create new models, new partnership structures, so that utilities might have some of the technologies and tools to do a little bit more for their customers and help their customers through this transition.
Great. Brett or Marianne, you guys look at this question certainly from a national perspective. Reflections on kind of Hendrik's comments about sort of the new market design. Are you seeing this happening on a national basis, international basis?
Yeah, I think there's something that Hendrik kind of touched on, which is super important and relevant here, which is having the right tool for the job. And that's going to be very regional and even sort of time dependent. So like if you're trying to satisfy the duck curve or maximize self-consumption of renewables, or if you're trying to shift load over a longer time period, or provide sort of resilience for electrified heating. Those are all, there's potentially different toolkits of demand flexibility and energy storage that solve those. And so we're starting to see some of those, and those need to be, those conditions sort of need to be reflected in the signals that are coming from the utilities so that we can all react to them. And we're starting to see those somewhat through like time of use rates, real-time pricing, but it's still sort of nascent, and I would say in some cases, maybe imperfect. Like the rate structures don't necessarily correlate to the CO2 savings, or they don't fully motivate the requisite actions. So I do think there's work to be done there, although it's definitely starting to show up, and there are things to react to already. There are really, I think, two different ways, or maybe there's more, but two potential ways where this could play out. And one is sort of an intrinsic organizational sort of aggregation mechanisms like rate structures, or other types of signals like this watt time signal that are out there that Saloni or other aggregators could react to those signals and modulate loads or shift loads appropriately. There's this FERC Order 2222, which now allows distributed energy resources to participate in utility wholesale markets. That's kind of a mouthful, and probably more something that somebody like Saloni would want to participate in. But what that would speak to is aggregators who are coming up with products, integrating them into our buildings and our loads and our vehicle charging and all that, and then using those to play in the capacity market as sort of a go-between. And so there's the two things. There's sort of the aggregator approach, and then there's also the sort of intrinsic reactive approach to rate structures or carbon signals.
Great.
Hey,
Mary
Stan.
Ann, would you, yeah, please,
Sorry,
Saloni.
I was gonna say, after Marianne goes, I'd just like to share one perspective. So if you
Mhm.
don't mind giving me a minute after Marianne, thanks.
Yeah, absolutely.
Yeah, I'll be quick also. Two quick comments. Department of Energy has launched something called the Connected Communities Program. I agree with the description that we have retail prices and we have wholesale prices. So we have these markets. But these connected communities there's 10 projects around the United States. And the idea is to try to create new business models for groups of buildings to aggregate their load and to bundle these GEBs. So we're requiring energy efficiency, grid services, and distributed energy resources. So EVs or solar or storage. So there's a lot of systems issues and a lot of like, how do we take, say, a city block or a campus or a neighborhood or a utility service territory and think about new business models to accelerate the deployment of grid interactive efficient buildings. And Ito's Connected Community is a really exciting one that they are going to help demonstrate new business models that have value to the local utility as well as value to the homeowner and building owner, and try to understand how to provide those technologies. So that's a really exciting thing. The other one is to go a little further on dynamic tariffs and retail tariffs. The state of California is trying to require that the utilities produce the electricity tariffs in a digital format. We call them machine readable tariffs, and that we will stream time of use or real-time pricing. So something called the California Load Flexibility Research and Deployment Hub, or CalFlex Hub, was funded to create research on what is, are buildings ready to receive continuously changing electricity price signals? Can a water heater, can a heat pump, can a grocery store or a school? And there's a lot of work that's needed to understand how ready are we to use prices to trigger this continuous load flexibility. And the state of California is including the greenhouse gas signal from watt time. So we're going to be streaming these prices. We're also looking at FM broadcast radio signals to try to get to people that don't have Wi-Fi that may be able to get a lower cost communication signal. So there's an exciting set of ideas and technologies and different sectors in buildings where we're trying to understand how to move the whole sector forward. And so there's some really exciting activities.
Saloni, I want your comments on all of this, both as both a market participant in this sort of new kind of business model, but also what Mary Ann just brought up in relationship to, we have 80 years of rate and regulatory policy in this country, largely leading to plain vanilla sort of utility rates, and how ready and receptive are you folks for things like dynamic pricing? So there's a bunch of questions in all of that. Tell us what's on your mind.
Well, I'm going to come back to putting you in my shoes or a fellow developer's shoes. The thing that we always have to be very careful about when it comes to incentives or dynamic pricing, we have to be careful, we developers, as to what are we passing on to our tenants? And I say that this is an important equation for us because any added cost increase, our first cost, because when we add all of this, the technology, the infrastructure, there is an added first cost to all of us. And the way we do it is that that added cost is built into the rent and it's built into our returns. And so when our tenants are paying the rents, in effect, that's how we're gaining back, what we've put into it. Also, we have leasing language that encourages, our tenants to participate in an efficient way of how we regulate our energy usage because there are some financial consequences. For example, in the city of Seattle, if you go down the target performance pathway and if you don't comply, there are financial consequences. So we have to really think about who's paying for all of this, and we have to be very thoughtful about our tenants. You know, with some of these programs, the only thing I would say to my fellow panelists is to just think about sometimes when we pass on cost to anyone and we filter it from us to them, we just have to make sure we don't overburden them. And the thing with incentives is sometimes we have to also be careful about we're not robbing Peter to pay Paul. So where is this incentive money coming from? You know, are we taking it away from another program? So I just want to put that out there for us to think about. It's not an answer, and I'm not pushing back against anything that's being said here. It's just another perspective that's our reality that we need to think about as developers.
Let me clarify, when you mentioned incentives, Saloni, are you talking about the incentives that comes from being able to react to different costs for electricity at different times of the day? Or are you talking about the more kind of traditional financial incentives, the kind of incentive payments that a utility might pay for you to participate in a particular kind of program? Is this latter one, direct financial incentives, kind of a precondition for you to be able to get over some of those cost disparities that you just mentioned?
Yeah, we've participated in, I would say, post occupancy incentive programs where we were told, hey, once you've actually installed everything, all the efficient measures that you've talked about, we'll come back and we'll give you a financial incentive. You know, you'll get a check from us, and we've done it that way with SCL before. Where we've also been approached with programs where they've said, hey, you know, that you can pass on. There's a way to, you know, have the billing of the usage. You know, when you get your bills, those bills can be passed on to the tenants. And so those are the kind of things that we worry about when it has to flow, when we're not the ones paying it, but the tenants are paying a higher bill. And it's sort of like this weird flow that I know I'm not articulating it very well, but we have been approached. And so when we come across things like that, it makes us think twice that, hey, we can't have them pay a higher rent for being in an energy efficient building, but then we also can't have them pay, you know, bypass the developer and then pay a higher rate. So those are the kind of things we worry about, because we don't know where's the money coming from in the incentive programs. And is it, like we say, is it robbing Peter to pay Paul? And it's not, please don't take it as a negative. We're also trying to explore this with you.
Right. Thanks. That's helpful. I want to turn the conversation now to, and in particular, this next section, we're going to be reacting to a number of items that our audience kind of pre-submitted in relationship to questions. Many of them are sort of in the category of, you know, what must happen and who's responsible for making it happen. The roadmap document sets a goal of a tripling of this market by the year 2030. So that's a substantial amount of activity in a relatively short period of time. So the question of, well, how do we make it happen, and where's the triggering agent to make that happen is particularly important. One of the things, and this, we touched on it briefly earlier, and I can't remember who brought it up. So Marianne, maybe I'll just have you start and we'll migrate the conversation around. But this is in particular about building controls and interoperability. How much more distance do we need to cover there, and what's involved?
Yeah, so one of the important concepts of interoperability is it actually levels the playing field for different businesses to get involved. So rather than having fully proprietary communications and controls, if we use open standards, then you don't get as much stranded assets. For example, if you have one vendor putting in your HVAC controls and another vendor comes and says, I want to help with your grid interoperability or retrofit your cooling tower, you're going to want to try to say, how do I decide what to invest in, and whether this company is going to have a long-term commitment to that network that we talked about earlier. So in the area even of grid signals, we have several standards, things like OpenADR or IEEE 2030.5 or CTA 2045, which are all important foundational building blocks. I'd argue we don't have everything we need yet, because we're still looking at how much can we deploy those now in a way that the control companies can easily incorporate them. And there's a lot of complexity still. Control companies are trying to figure out how do I use that technology, and how can that technology evolve? We have things like electric prices, and we have ancillary services, and we have batteries and building equipment and EVs, and we want to move towards, just like you have PCs and Macs, a couple of operating systems. You don't have to have just one, but you do want to know how they plug and play, just like our software can plug and play. So we want to continue to improve our ability to help integrators and utilities and vendors have an ecosystem where we level the playing field with more interoperability.
Yeah, Saloni, please.
I'm sorry. This is, by the way, Marianne hit upon something that is hypercritical. And this is something we've seen from our end. So when we did our network architecture and we started this at the schematic level, we were very clear about this, and we've run into this, that if we don't have open protocol for communication, we are in big trouble. Because if systems cannot speak to each other, and if they're proprietary based, that is something that becomes very restrictive. And so as a philosophy at Urban Visions, we had to educate ourselves in real time and make that the #1 criteria. With McKinstry was our technology designer. And so we worked very closely with them to make sure that when we set up the network diagram as to which systems were speaking to whom, everything had an open protocol system in place. Of course, you have to balance that with security, totally understood. But to Marianne's point, the moment it becomes a proprietary system and you can't speak to other systems out there, you've just got off the flow of analytics and the flow of communication, and or the building being an operating system to then overlay any of these other programs.
Great. Hendrik or Brett, anything to add there?
I think there's also just, I want to address the comment about tripling the market by 2030. We're going to do it, right? We have to do it. It's the most cost-effective way to decarbonize buildings is to make them more flexible. And I think that what Marianne and Saloni spoke to as far as interoperability and communication protocols is super critical, right? Our control systems need to be unlocked. The data needs to be democratized, and we need to be able to act across a multiple way of interventions, right? Different types of vendors, different types of business models. I think that part of the reality is existing buildings are, suffer from a lot of deferred maintenance and suffer from a real labor shortage around qualified technicians. And so I think we have to also think about, a rural school district that right now is running their buildings 24 hours a day because the custodian doesn't know the control system very well, and it's very hard to manage those systems, and make some of these systems simpler. And we have to provide additional support. And, this idea of the utility, we're working with the utility right now where they're actually deploying an energy management information system in supporting their customers and taking advantage of that system. And it drives cost-effective energy savings, but it also creates the pathway both from a business model and from a technology to roll out flexibility programs and to do it in a way that's more equitable across their whole service territory, not just, a market-based model that, the Microsofts and others, not to pick on Microsoft by any means, but just, sophisticated clients will be able to take advantage of, and many will be left behind. So I don't have the answer to that other than, utilities do, I think, have a role to play and to help support the standardization, the open protocols, and enabling this across lots of different buildings and lots of different customer types.
Great. I want to turn to another area that was posed by our audience, that in order to sort of make this goal laid out in the roadmap, that we need increased confidence that GEB technologies can really deliver firm resources in a timely manner. So Brett, I'm wondering if you could address that. You know, what has to happen in order to create that confidence, and who's responsible for making that happen?
Yeah, it's so one I'll say one thing, and then maybe I'll pass it to Marianne, because I bet you could talk about California and other things about that. But one thing that we've sort of looked into as far as confidence and achieving the desired results is the nature of signals, both in terms of the level of advanced notice on signals, if we're doing load flexibility in response to grid needs and conditions. So advanced notice, and also the time step. Is it a tight time step, or is it sort of more coarse? And if we do a bad job of both of those, they can kind of compound, and actually you could miss out on up to 2/3 of the would-be CO2 savings opportunity. So the nature of the time step and the advanced notice matters. Also, open access to regional granularity and transparency of data is still an issue in some places as well. And so we need those things so that we can react appropriately. That's part of it. I know there are also some things about the sort of statistical baselining, and California is kind of leading the charge on this. There's some people working on appropriate baselines, and then, you know, how do you measure the thing that didn't happen? That's kind of what it comes down to. And I don't know if others on the panel want to speak more to that, who are perhaps more in the weeds on it.
Marianne, reflections from California?
Yeah, so I actually just put in the chat for all of our guests to look at the demand response enabling technology research studies. These are funded by the investor-owned utilities, and it's a list of things that they've been doing over the past 5 years. And those are all public studies. We participated in many of those. So they actually test, they prior to being included in a demand side management utility funded program, they'll invest in these case studies in the field. So we want to do as much as we can to prove these things and publish the data. And there's a lot of that out there. A lot of work these days on heat pump water heaters, a lot of work on heat pump flexibility, an emerging set of technologies on integrating with batteries, virtual power plants, smart thermostats. That's one I think there's a lot of work on. Bring your own device, bring your own thermostat programs. So we move from devices to programs, but we want to keep an eye on customers. You know, what has the customer experience been? Have they saved money? And we, of course, have the traditional demand response technologies. And that's really kind of the evolution that we're talking about, is moving from, 10 events per summer to a continuous communication. And that's where we don't have as much of these case studies, that we really are moving towards trying to make sure that the spring performance and the winter performance, and not just the hot summer days, are part of the value proposition for the customer bill and for the utility grid integration.
I think, just to add on to that, I think the most important thing is that two-way communication, right? It's the ability to have over time information sharing so that you can see the types of interventions and what they resulted in. It's always hard, right? It's hard on the energy efficiency side too, to measure something that didn't happen, right? So the idea of load flexibility is that loads are shed, and sometimes it's hard to see that because you don't know what the building would have done otherwise. But having that rich data sharing allows all the parties to create forecasts and models and expected loads so that you can actually measure against that. You're not just saying, did it get the signal? But you're saying, yes, it got the signal, and we anticipated it would have looked like this had we not done an intervention, and instead it looked differently. The other thing that helps is to get to scale, right? A single building, and I think one of the challenges with demand response is a lot of utilities had one or two big significant loads, a paper plant, something like that, where they would just call up and say, hey, shed your load, we're having, we're in a crisis. The problem there is you don't have the benefit of sort of, at scale statistically, right? If 95% of our assets always respond and we forecast that way, over time we can build more certainty and more confidence in the overall response, even if an individual asset is offline for some reason.
Great. I want to, and Saloni brought up this issue related to this a bit earlier, but one of our audience wanted to know about the split incentive problem. Seems like this issue is kicked around for my whole career. I have 35 years of talking about split incentives, and here we still are. But they wanted to know, is that a deal breaker for widespread GEBs deployment? You were talking, Saloni, about the distribution of costs and benefits, and this is at the heart of kind of the split incentive problem. Is it a deal breaker, or are we talking about being able to finesse this issue once again?
Can I ask a clarifying question?
Sure.
When you talk in terms of a split incentive, just tell me what you mean by that.
Okay, well, the other three panelists could do a better job of this than I can, but I think this is the notion that as the building owner developer, that you're responsible for capital costs and ensuring kind of what systems get put in the building. But oftentimes the energy costs are borne by the tenants themselves. So there's some spread here between the costs and the benefits associated with these kinds of investments.
So the one thing I will say, sorry, before any of you answers, we're in the Seattle area, we're a triple net. So everything, so I have to give that context compared to other parts of the country, because everything is passed to our tenants. So when you heard me talk earlier about, hey, we have to be very thoughtful about what's passed to the tenants, and whatever the incentive structure needs to be, it's because of the market that we're in. So I can't claim to know the nuances of all the incentives out there. The only thing I can share with those setting up the incentives are two things. Is like we say, just make sure, where are these incentive dollars coming from? Let's make sure we're not, shooting ourselves in the foot at one end and then providing dollars in the other. The other thing that I would say, and I say this about who we are as a company and personally as a professional, I hope that these incentives are also there for a lot of the low-income housing, people that don't necessarily have the deep pockets that, developers like us do, or who can afford to pass it on in the rent option, the balancing of that pro forma. So those would be the things that I would say to people setting up incentives, is just be mindful of that, and also mindful of where you've got a triple net set up versus not.
And other comments?
So we're actually starting to think about what we're calling transportable technologies for home decarbonization. Transportable heat pump water heaters, transportable heat pumps, transportable small washer and condensing dryer combinations, so that if you give it to a tenant and they own it, they can actually take it with them to their next location. So it's not actually connected to the building. So that's the team at Lawrence Berkeley National Lab has been brainstorming on that. And it's one example of trying to think about equity and trying to think about the electrification and decarbonization.
Wow. Your washer, your dryer, and your heat pump all in the, that's fascinating.
Load it in your trunk.
I hadn't thought about that. Excellent. Hendrik or Brett, anything you would add to this question? I have more if you don't.
I do think that we're seeing some emerging financing products that are designed to help address these problems. So in larger commercial buildings, there's PACE financing, which is generally for larger projects, kind of more complex, and Saloni, correct me if I'm wrong, but I believe that PACE financing can essentially be paid or passed through to tenants and align capital investments with the tenants who are benefiting from it. And also on the more residential side, there's on-bill financing or pay as you save, which is sort of a variation on that, which allows individuals to basically finance or obtain efficient equipment via their energy bills. And so there are some innovative mechanisms like that that are geared towards trying to solve the split incentive that's been around for 30 years or however long. And I'd be curious if the nature of the split incentive is in fact different with grid interactivity, or is this the same story as energy efficiency? I haven't really thought too much about that, but I suppose if the interoperability becomes the default on our equipment and our systems, and it's somewhat automated and fail safe, especially for low income customers, it seems like something that could be overcome as the market evolves.
Great. Well, I noticed that we're at the top of the hour and we are pledged to end today at 1:15 Pacific time. I have a boatload more questions, but I'm going to try to condense those down into a few we can get to over the next 15 minutes. I do want to ask a little bit about the workforce. People have raised the question here whether or not this technology that we're talking about deploying in buildings is beginning to, if not already, outpace the sort of skill levels of the folks that we have operating and maintaining the facilities. How important is sort of workforce skill development to making all this happen?
Want me to go first?
Please.
Sorry.
You're actually doing this stuff, so yes.
Very important. And I say this as, I want to use the word support and I really with empathy, when it comes to supporting, continuously educating our operators. We at Urban Visions are really lucky, my colleagues, our chief building engineer, and everyone that we hire, one of the things we really emphasize, and we continue to, pay for any education that they need, is on the technology side. And yes, a big part of there, from a maintenance point of view, there is the whole bricks and mortar, walk around with a hammer, but you're also very savvy on the software technology. Hey, what's happening, what's changing in the industry. So it's something that I think it's an investment into our people and our operators that to really bring them along. And yeah, and they're like gold. I will say those who are out there who get this are just, gonna put a price on them. So super critical.
Yeah. Hendrik, I suspect that this question is part of your day-to-day life. What's your view on this?
Yeah. I mean, the last thing that building operators need today is more complexity, right? They are juggling all sorts of comfort issues. We're juggling the last 2 years of indoor air quality concerns and COVID, and the explosion of technologies combined with aging of building assets just creates a really, kind of a perfect storm of a really tough job. And we don't have enough folks that have the experience to do this work. That said, I think this also creates a new value stream, right? So hopefully it creates more benefit to the building. So maybe it enables a building that has an outdated control system with poor graphics and no analytics that allows them to invest in maybe advanced analytics that Marianne mentioned, right? There's tools out there that have kind of limited penetration into the market, but could be really beneficial in helping operators save time and be more impactful. So I see the optimistic side of it, which is, hey, this is one more value stream that might enable us to invest in the tools and the kind of digital transformation of buildings necessary for operators to do more with the resources they have. But it's a big lift, and it's a big challenge, and organizations like Smart Building Center and others are playing a key role in helping educate and inform. And the Building Operator Certificate Program is an awesome way for folks to continue to furnish their skill sets, and we just need more of that.
The thing I want to add to Hendrik's, I also want to put responsibility on people in my position or on the front end of the development side. Another thing that at least I do is when I do my job, I always begin with the end in mind. So a lot of the design work, I have my operating team, our maintenance team, our chief building engineer in those design meetings. I also want, because at the end of the day, we're going to hand this off to them. And to Hendrik's point, my job is to make their life easy. So if we begin by saying, hey, how does it work on the pragmatic end? What do you need in order to run this efficiently? What is the technology that, deployed now, and 3 years later, it's actually going to be a living, breathing building. So along with them feeding into the design is also, we're bringing them along from an education point of view, so that once the assets developed, their knowledge base to run that building is in present time.
Saloni, I want you to run for national office on that platform. You got my vote. One other area of conversation that I want to turn to quickly for the next 5 minutes or so before we do our sort of lightning wrap up round set of questions is a question that came up last week that resonated with a lot of our audience in terms of talking about scale. How we think about this resource appropriately in relationship to scale. And both Hendrik and Marianne mentioned a little bit about connected communities, but I want to unwrap that a little bit more in terms of the necessity of thinking about this resource, if we're going to get to the tripling by 2030, as more than an isolated building here or there, and how this resource appropriately scales. Marianne, do you want to open up a little bit more about what you all in DOE are trying to achieve out of connected communities?
So the vision is to invest in 10 sites around the country, and the sites are all different. Some are retrofit, some are new construction, some are residential, some are commercial, some are campuses, so that we understand how we can work with groups of buildings, not just individual buildings, to deploy grid-interactive efficient buildings. So really, that's the main idea, is that there are 10 of them. I'll actually drop the website link into the chat for people to take a look. And the program is just starting. We'll be working with them so they know each other, and we're going to have common measurement and verification protocols. So we'll be collecting data on what did the customers think? How cost effective was it? Was it valuable to the utility? Did it reduce greenhouse gas emissions? Is there business model innovation? What were their interoperability challenges? What are their cybersecurity challenges? So it's a broad, almost everything we've been talking about. There will be pieces of this multi-year program that use these demonstration sites to tell those stories around what's working, how well did it work, and how can we share what we learned from that investment in grid interactive efficient buildings at the multi-building scale.
Well, and Hendrik, is my understanding that Ido is actually one of the 10 recipients. Comments on this question from somebody who's going to be now one of the doers?
Yeah, well, we're super honored to be awarded one of the grants for sure. I think that the scaling, just requires us to think differently about the historic structure, right? We had this utility model that worked well for 100 years, and as technologies changed and as our social goals have changed around carbon and other things, we just kind of rethink it. So we're excited in Spokane to be able to demonstrate at the substation level how we can have really significant impact in kind of a neighborhood approach, feeder by feeder, and link all those buildings together, even if the building types are very different. And we're going to try to explore the kind of the combined flexibility of a whole neighborhood versus the individual flexibility of a single resource. Other projects are going to be much different, and we'll learn, just like Marianne said, we're going to learn from one another. We're going to share data, and hopefully at the end of this or midway through this, even better, we're going to start to see some patterns. And I think it's dependent on what the grid mix is and what that local what the local conditions are, and also how we structure programs that ultimately consumers adopt, right? We can dream up all sorts of cool things that we think buildings should do. And if building owners and operators don't feel incented to do it, or don't feel like this is an easy thing that they can make happen, we're going to be, dissatisfied with the adoption. So I just think that we're in a stage right now of doing a lot of discovery and really trying to validate what are the best mechanisms and best tools to use in addressing this problem.
Great.
And
Okay,
I mentioned
yeah,
too,
please, Brett.
we're actually going to be involved with one too in Madison, Wisconsin, team led by Slipstream, working with the city of Madison, a portfolio of their buildings, as well as an EV fleet, which is something we haven't really talked about today, but EVs are plugging into buildings. And so we're excited to work on that also with Madison Gas and Electric.
Great to know. I didn't realize that, Brett. That's really good news to know, and I'd be happy to follow the progress. Sort of a final set, and I'm gonna unfairly put you in teams, and ask you to maybe take 1 minute each here. And this is the two teams advising one another. Marianne and Brett, what advice do you have for folks like Hendrik and Saloni, who are really turning the crank in terms of creating and maintaining the built environment? What do you need from them? And conversely, Hendrik and Saloni, Brett and Marianne get up every day and work on this question in terms of, what can they do to facilitate these market transactions and market development? So each of you take 1 minute, if you will, and tell the other folks what you most need from them. I'm going to start with Marianne.
So Hendrik and Saloni are sort of the dream team. When we think about communicating with owners and innovative businesses, we would be thrilled to have more people like them. So we want them to be innovators and early adopters in their community, so that they tell people what they're doing. So I'm super impressed. I'm going to say something technical. Hendrik mentioned HVAC and COVID. Our HVAC facility managers now have been spending years thinking about, how do I get more air into the space? And they need exactly the opposite when we have these smoke events that many of us know. And so, but they have something different when they have a grid event, and in California, we have these public safety power shutoffs, and you may be on backup power. When we do something like demand response, we're often running the building into some kind of low power mode. So we're trying to maybe get by on 50% power for 2 days or something like that. So we have all these new modes, grid integration, COVID controls, smoke event controls, all these modes. And the facility manager saying, wow, how do I please everybody? How do I make sure I'm saving money on my bill, working with the utility, making sure that I'm managing the smoke event? And I just want to acknowledge the challenge for the controls companies and the owners and operators to think about making sure that as we think about our buildings, we kind of look at not just GEBs, but this broader issue of health and economics, and help them feel like they're part of the team. We're not just telling them you have to do this now with your building, but we're helping them be creative partners in these solutions.
Great. Brett, RMI is a gold standard voice in this conversation. What do you need?
Mine will be short and sweet. We'd like to hear what the barriers are from you, because we're in a position where we can kind of straddle the implementation and the sort of the policy or regulatory environment. We've got some hypotheses about what's needed to smooth the integration and the rollout of that FERC order 2222 that I mentioned earlier. But that's one piece of it, and we'd like to know what the things are, the multi-stakeholder problems are that we could help to address that are perhaps outside of your day-to-day job description, but we could tackle. So now you're going to respond and tell me exactly what those things are, right?
That is the question. I'm going to give both Hendrik and Saloni 30 seconds each. Hendrik, start.
I'll go quickly. I think we need to continue to accelerate the innovation. So more opportunities for demonstrations and pilots and grant funded projects. These are two risk averse industries, right? Buildings and utilities are not fast moving, and we've got to just accelerate that pace of innovation through different programs. And then the learning that'll come from that, I think, will feed to what you asked for, Brett.
And I would add to that to say that when Marianne, Brett, and when you talk to developers and asset managers, use a language that we understand. Make sure that it's in terms of carbon footprint, CO2 emissions, reliability for tenants, bottom line reductions of operational costs. So things that, that touch our world. The second thing I would say to you and also to other of my peer developers and designers is, in order to enable GEB or any other programs in the future, our buildings must be designed as technology platforms. Consider them the operating system over which you could then overlay future applications. Future-proof them today so that they're flexible and resilient 20 and 30 years into the future.
Folks, this has been an absolutely fantastic conversation. At the conclusion of last week's panel, I said, well, week 2 is going to have to really step up their game to have as good a conversation as we had in week 1. And you've more than met that challenge. Thanks to each one of you for a really interesting conversation today. I really appreciate your expertise. Before I let our audience go, I just want to share with you all this site, which is now live, the Smart Buildings Exchange, which I mentioned at the first, which is our annual conference at the Smart Building Center. A combination of both some virtual and in-person sessions will be August the 22nd through the 24th. If you want to migrate to the conference site, the registration is now open. I can't guarantee, but I can almost guarantee that the personalities who commented to you today will hopefully be part of the showcase that we have during this conference. So with that, I realize that we're out of time. Finally, with my thanks again to the panel today, we appreciate your participation and hope to see you again in another one of our events. Thanks so much.
Thank you.